Thank you very much for being here. I would like to start by welcoming you on behalf of our rector. He cannot be with us today because he has a previous commitment and he is chairing a board meeting, which I will join after this opening. Let me thank everyone involved here today. I'm not sure if I am going to pronounce properly. Maciej, Grzeszczyk, Nives de la Valle, Cruz Borges, Thomas Nacht, Carlos Quesada, Leira Estigarraba, and especially Chris Merbley, who has accepted at the very last minute for moderating this event. Today, we celebrate an open day in the framework of the EU Green Week, as Chris mentioned before. It will be an opportunity to engage with the stakeholders, policymakers and citizens, and to discuss how we can work together to achieve our ambition for zero pollution and toxic-free environment. The session will deal with the energy system model that can best help reduce pollution and present different use cases. The session, entitled Predicting the Impact of Household Behavior Intervention on Environmental Pollution, organized and run by the consortium of Y Project. For me, this title inspires me the following reflections. The first one is that we only have one planet, only one Earth. We are not planning to go and live on Mars. And Europe's future depends on a healthy planet. If we, as human beings, want to survive, we have to change our way of living and our habits starting at home. The EU is committed to achieving climate neutrality by 2050. Achieving this goal will require a transformation of European society and economy, which will have to be cost-effective, fair, and socially balanced. All measures to be taken must be based on both technological advances and behavioral changes. The title also connects directly with at least two strategies. The external one refers to the smart specialization strategy with the triple transition. We should assume that the three are deeply connected and interrelated: the green, the social, and the techno-digital. The internal one in our university, which refers to our so-called 6 Eyes model. This is our research strategy based on a very basic principle. We are a medium-sized, non-intensive research university, and we are very aware that alone we are weak. With others, we become strong and competitive. The 6 Eyes model refers to 6 keywords, starting with the letter I, that make us stronger: international, interdisciplinary, intersectorial, impact, innovation, and inclusion. Let me stress today some of them. The first I responds to international collaboration, including other countries and other territories. The second one aligns with interdisciplinarity collaboration, as we have had a group of researchers from different fields working together. The third I, the intersectoral collaboration, has actively involved other stakeholders and agents. The fourth I responds to impact, an impact that transcends scientific impact. Today, we focus on the societal impact to explore different recommendations for policymakers and best practices to change our consumption habits at home. The fifth I responds to innovation and refers today with the way we deal with the triple transition, deeply connected: the green, the social, and the techno-digital. And last but not least, the sixth I related to inclusion. We are deeply committed to the participation of every person, regardless of their situation, gender, economical situation, religion, faith, or wherever other dimension. Today's session encourages all citizens to reflect and change their lifestyle and consumption habits at home. I'm confident that this morning will be fruitful and enriching for everybody. Thank you very much for being here and for participating and for being willing to enjoy all together.
Thank you very much, Rosa, for your intervention and for your words. I think they're inspiring. So yeah, thank you for taking the time out of your day to give us this introduction. I will now pass the word to Maciej Grzeszczyk of DG Energy, who will also give an introduction from the Commission part.
Yes, good morning. I assume that I should share my screen, so that's see the presentation. Yeah, good morning, everyone. Thank you for the invitation. I hope you can see the presentation, you can hear me. So if this is the case, if someone can confirm, so I could.
Yes, we can see it, but not in presentation mode. And there's a big black square on the right.
Okay.
Which is probably where you have the view of the speakers or something like that. If you can reduce that window.
Oh yeah, yeah. Well, I'll start the presentation and hope it's gonna be better. Is it fine now?
We still have the big rectangle on the right hand side, which is, like I said, probably where if you can minimize that, then because I think that's where you will see the talking heads. Yes, that's already better. If you now drag it to the top, all the way to the top right, then
okay. Maybe I should. Okay.
Great.
Is it acceptable? Yeah.
Yes.
I know
yes.
you
Thank
can
you.
see it. Okay. Thank you. So yeah, I'll give you a brief presentation on the importance of energy system models in energy policy making, mainly from the energy efficiency perspective as an introduction, because it indeed is quite important to us, and we use energy system models quite often and other models. So I probably go a bit wider in my presentation. As a beginning, I will start with this slide, which is used from the Sentinel project, where there was some analysis how energy models could be used for policy making. And you can see that there could be various levels of interactions. And I've seen two versions of this slide. And in this one, you have the arrows going in two directions, meaning that there is also some influence from our side on how the model is performed, how it works. So first is the agenda target setting, then policy formulation and adoption, policy implementation, and policy evaluation. I would say that we don't use it to the same extent in all those four areas. So indeed, for exploring, which is the first agenda target setting, preparatory models are used quite often, and usually these are in various studies and research projects. And your project Y project is one of those, and we try to follow them quite closely to see what they deliver and how we can use them for better policy formulation. Then where there is a key use of models is for the impact assessment. I think we are pretty much obliged to use quantification as much as possible, and use of energy system models, I think, is now the common practice for all the energy policies. And I will present what is in the next slide, what is the common modeling suite that we use for quite some time now, although we also try to use different tools. In policy implementation, I would say that there is less so use of the models, probably because also we are a bit a higher level at the EU level. So we pretty much rely on what is going on at the member states level. So for this, there are some studies and research projects as well, but this is probably not the core use. For policy evaluation, we mainly try to use the past data, but there is also some use of the counterfactual scenarios and models for this purpose. But I would also see that there is more evidence-based evaluation, which is the preferred way forward. But I think for all those four areas, there is importance to have some appropriate and relevant modeling suites. So this is what is now the I think pretty much standard modeling suite that we use for energy and climate policies. This has been used for the climate target plan, and has also been used for the upcoming Fit for 55 package. So we mainly use Prime's model, but it's accompanied by different different models, prime stream of Bose JRC, and when we talk now about mainly about air pollution gains model. There are also Capri and Globule model. I will not go into details. As you see, it's quite complex and there are various interactions. But I think what is important that we try to be as comprehensive as possible. So we try to model as many aspects as possible and try to see how they work with each other and how they could be used for as wide as possible capture of the economy and the interactions at various levels. For energy efficiency, how we use the models are, well, I could give some overview what we use from primes, because we focus mainly on the demand side. So future projections of energy demand are quite important for us. The starting point is usually the reference scenario that is updated every couple of years. There are also scenarios capturing the existing policies and scenarios capturing additional measures. This approach was used for the assessment of the NECPs. We ask for this to be used by member states. We also try to do it at the EU level. And now the new reference scenario would be something reflecting the NECP. So it's probably something between WEM and WAM. We also try to capture new trends and developments, so societal trends, behavioral and technological changes. This is quite challenging how to reflect them and what to expect from the changes that we would like to see or the changes that are happening, because they also will affect how the policies should be formulated or could be formulated, what would be the impacts of those. And well, this boils down to the main use of the models, which is the impact assessment. And in our case, we focus very much on wider benefits because for energy efficiency, when we talk about cost benefit analysis and cost effectiveness, we always emphasize the wider benefits of energy efficiency. And one of those is actually improvement of air quality. And it's both indoor air quality, but also because of the reduced use of fossil energy, wider improvement of air quality, either in the local areas or in general. And as I said, concerning the evaluations, we also used some counterfactual scenarios, but as I said, this not necessarily might be the best solution, because if we use the model for the impact assessment and then we try to evaluate the impacts with the same model or a different model, it's become a bit theoretical, but still it's quite a useful exercise. And as I said in the beginning, we used this two-directional, I used this two-directional relations in the first chart, because we also try to see how the model works. In order to be used, we have some preconditions, and we have to be sure that the quality is sufficient and we didn't know what is put in the model. It's not the best solution for us if we have a black box approach and we just receive the results and then we have to explain it to the wider public or the policymakers what has been put there, and there is a big scrutiny of macroeconomic projections, future costs and prices that are used for the model, also technology assumptions. So whenever we use the model, we have to be sure that these are widely agreed, these are consulted with stakeholders, consulted with member states, and are acceptable and as close to the reality or the agreed approach by wider research community. Also, data inputs are quite important. As you know, we are primarily using Eurostat. There are different data sources that in some cases could be more granular, but for us it's quite important that we use Eurostat because this is the data source that is used also for evaluations and monitoring. So this consistency, even if at the expense of accuracy, is quite important. One big thing is the representation of policies. So the interactions between the policies, what are the impacts, how they are put into the model are quite important. We have still some big difficulties how energy efficiency measures can be captured by models. Now there are some bigger granularity, for example, in the primes model with the building module, but still there is quite a lot of things to be done because We still have not that much data, maybe from the evaluations, also how the policies worked in the past, and on this basis we could probably also improve models, and this is quite a big challenge. And of course there is also validation of results, some reality check, what is the outcome, if it's realistic, if it goes with the expectations, how big would be the impact on the economies in terms of costs and investments, if things could be happening. So we also have to take into account that even if models are supposed to deliver some representation of reality, but we have to do some reality check of those. So as you can see, there is this two-directional relationship. And I think this would be from my side. I would just emphasize that we do look at various models and we try to improve them, and we will keep on doing this. So it's quite important for us also, this project, to see how all energy system models and other models could be improved. Thank you.
Thank you, Maciej. I think it's very interesting that you framed very well where our project fits in, what our objectives, where we contribute, how it's used in the policy, and how we can, well, it proves the relevance of the work we're doing. So thank you very much for that. Now we're already running a little bit late, so I will immediately give the floor now to our main keynote speaker of this first part of the session. It's Nives della Valle. She's a researcher at the European Union's Joint Research Center at ISPRA in Italy. So Nives, please go ahead.
Thanks a lot, Chris.
I think, Maciej, you need to stop sharing your screen. Sorry, Nives, I interrupted you. Please go ahead.
I just wanted to thank you for the invitation. It's an honor to be here today at the European Green Week partner event, the Y project. We'll just now share my slides in a second. You should see them, right?
Yes, we see it.
Perfect.
Thank you.
So here we are. Thanks also for the introduction. It's really an honor to be here today. And today I will mainly talk about why the behavioral factors should be included in energy policy making. So I will give mainly a behavioral perspective to all energy policy issues. As I said by Chris, let me see. Yes, I come from, I work at the European Commission and mostly at the Joint Research Center, which is a DG of the European Commission. We are the in-house service of the Commission. So we are researchers providing scientific evidence that can help the policy making process. And specifically, I'm part of the Energy Efficiency and Renewables unit. So the unit is mostly made of engineers, but also economists and behavioral economists like me. So we help policy DGs, especially DG ENER, to co-create the policy initiatives and legislation on energy efficiency and renewables. So just to start, I will just briefly summarize the context without going too much in depth, as it has also been highlighted by Rosa earlier. So we are in the context, of course, of the Green Deal, that is this big ambition that the European Union has set in order to make Europe the leading world power in terms of carbon neutrality by 2050. And so that means that there should be a lot of effort from all sides, not only from member states, but also from citizens, in order to help achieve this ambition. And within the Green Deal, of course, we can mention the Renovation Wave, which is one of the recent initiatives that was launched last winter, that has the specific focus on the building sector. And why there is this focus? Because the building sector somehow is one of the main polluting sectors in Europe. And that means that if we are able to make more energy efficient this building sector, then we are able to really untap a lot of potential for energy savings, and so we are able to contribute to the achievement of that ambition of carbon neutrality that we mentioned. So what it is, the energy efficiency, of course, it's one of the main results of the technological progress that has been made in the last decades, and that enables us to achieve this ambition. And so we can think of energy efficiency measures, especially in our houses, if we want to, for instance, adopt insulation measures, or if we want to adopt some appliances that provide the same energy service, but that use less energy. That is the so-called win-win solution that we would all like to achieve, both for the benefits that are provided on the environment in terms of reduction of emissions, so less pollution, but also for us as citizens who can see in the future, in the long run, savings in terms of budgeting. So there is this win-win solution that is a policy ambition itself to help the decarbonization goal. At the same time, we see that actually, despite this potential, the level of adoption that should be social optimal is not achieved. And in the literature, in the scientific literature, this is called the energy efficiency gap, and has been really at the focus of several studies that try to understand the causes of why people, citizens, don't invest as it should be, despite this plethora of benefits that, as we said, can be provided for both the environment and the society. So scientists somehow have investigated these reasons behind this suboptimal adoption level from different disciplinary perspectives, but we can say that the perspectives that have informed the policy debate have mostly relied on those perspectives that focused on the barriers and drivers of the decision to invest in terms of cost information. So let's say a purely economic perspective, but we can say that economics is only one of several social sciences. There are some other social sciences that might inform better the policy debate and also the design of interventions that might better support the promotion of this investment in energy efficiency measures. And an example is, of course, the insights from behavioral sciences such as psychology and also behavioral economics that have recently started informing the policy debate. Of course, just to give a bit of background of why it has been used, this approach focusing mostly on information and economic savings to design in the interventions to promote energy efficiency investment. And the reason why is that somehow there has been for decades the assumption that individuals might only change their behavior, and so might be motivated to invest in energy efficiency measures only because of economic reasons, or only because they have enough information to make this choice. And so given this assumption of how individuals behave, policymakers have, of course, designed interventions accordingly. So to motivate this energy efficiency investment, policymakers design, of course, tax and subsidies, provided some change in the options available, so through regulation, or increase the information provision such as through labeling. But actually, the empirical evidence coming from the behavioral sciences highlighted that individuals actually don't make only decisions based on economic reasons or the information available, but rather decisions mostly depend also on the availability of cognitive resources, which are often very limited, with the result that decisions such as failing to invest in energy efficiency might be suboptimal, because we are not able to really make rational decisions in the proper sense by really computing the cost and benefit associated to that decision. And the risk is that we make systematic error. But at the same time, the error that we make are also predictable. And so this predictability and this systematicity of errors is actually very powerful from a policymaker point of view, because it means that there might be some drivers or barriers underlying the decision to invest that might be actually useful for designing interventions if properly detected. And so here there is a non-exhaustive list of barriers and drivers that go beyond the purely economic perspective. So they try to understand why people might not invest in energy efficiency measures, or why they invest, so why they are motivated to do so. And particularly, there might be some intrinsic motivations, if we might be allowed to define them so, that might actually be very cost effective as to be considered as a lever to be used by policymakers, such as pro-environmental preferences or personal and social norms. So there might be some people that, even in absence of incentives, might be already motivated to invest in energy efficiency measures. And so if really able to detect these people, then there should be also some kind of saving from government point perspectives, because we all know that subsidies and financial incentives are, of course, costly for the policymakers. Of course, these people should be also have budgeting capacity. So we might also consider that these intrinsically motivated people should also be kind of, should have the financial availability to do so. But if we consider that they have the financial availability and they are intrinsically motivated, then this is something that the policymakers should consider. Behavioral sciences also highlighted that, as I said, there might be a way to make more effective traditional instruments such as subsidies and financial incentives. And so, as I was mentioning, there might be this augmentation of the efficacy of traditional instruments by targeting the financial incentives based on the motivations that are available in the target population. So this is a way in which behavioral sciences can help policy interventions, traditional interventions, to be more effective. And this is crucial because in addition to, let's say, enabling savings from a government perspectives, tracking, for instance, motivation in a target population might be also crucial to avoid the so-called spillovers. So if an intervention like the price incentive is able to determine a change in behavior, so to promote the increase in energy efficiency investment, it might be the case that this positive behavior change might also spill over to another policy domain that was not intended by the policymaker, but it might be that this price incentive might also crowd in a positive behavior change in another policy domain. On the contrary, if the price incentive crowds out the intrinsic motivation in a target population, because in that sense, individuals feel that they cannot show off their effort to comply with an existing social norm that says that the norm is investing in energy efficiency, and so people want to show that they are paying a lot of money to comply with the norm. In the presence of price incentive, there might be some negative consequence, because the price incentive prevents people to show this effort off. And so instead of promoting an increase in energy efficiency investment, it might be that the price incentive decreases the willingness to invest in energy efficiency investment if there is this intrinsic motivation. And for the same reasoning as mentioned before, the spillover might negatively occur also in other domain. So there might be some kind of mechanism that have to be taken into account, because the unintended consequences might be costly for the policymaker point of view. Another thing that behavioral sciences highlighted is that not only they can augment the efficacy of traditional instruments, but they can also offer additional instruments to promote behavior change, and in this situation to promote an increase in investment in energy efficiency measures. And for instance, we can mention here nudges and boosts, which are costless interventions that usually work on the provision of information, on the framing, or they also try to provide some options that are not cognitive demanding. And so just to remind us that we are bounded rational, so we might make optimal decisions if the choice environment is designed in a way that accounts for that. But it might also be the case that a nudge, such as the provision of the provision of option to self-present, to present our effort in a social context, might be a way to try to attenuate that unintended consequences that I mentioned earlier, when there is the implementation of a price incentive. And so in a target population, of course, we are heterogeneous, and so there might be people who are intrinsically motivated to invest, and people who actually need that push from an economic point of view, and so they need the price incentive. And there might be also people that actually cannot afford the energy efficiency measure. And so to avoid the crowding out of the intrinsic motivation, there might be the option of also including a nudge, just to crowd in that potential crowding out of intrinsic motivation that might occur. And so this is an empirical question. I should disclaim that will be the topic of a project that that has just started. And so if you want, you can we will keep us posted on the progress of on this empirical question that will be answered through the experimental method. And so I would just like to conclude sharing with you something that also Maciej highlighted, so that for policymakers, what is really crucial is the quantification. And one way to actually exploit the power of behavioral sciences for energy, for policymaking in general, and in particular for energy policymaking, is to really test and provide a quantitative estimate of the efficacy of a behavioral informed intervention, so an intervention that takes into account this behavioral factor. And one way to do so is to run a randomized control trial. So the, as you might be familiar with the medicine world, there is this assignment of a treatment to a certain one group, and the assignment of a placebo treatment to another group. And this is one way to really provide the perfect estimate of the efficacy of interventions on a desired behavior, such as energy consumption or the investment in energy efficiency. There are questions of feasibility, of course, and whether this is the only method that we can use to provide the quantitative estimate. And of course, there might be other methods that can be more suitable, because randomized control trials are very costly and takes time, and so sometimes they are not feasible. The other challenge is that behavior right now is considered and investigated from an individualistic point of view, and that's the point of view that is mostly taken by the disciplines of economics and psychology, and so the behavioral sciences. But the next challenge will be also to account for those social aspects surrounding energy behavior and energy efficiency investments, which are mostly taken by perspectives such as sociology. So perhaps this will be the next challenge for the science policy interface. And so with this, I thank you for your attention, and I will be willing to answer your potential question. Thank you.
Well, thank you very much, Nives, for that very interesting presentation, especially the insights you're giving from behavioral economics. I think they're very valuable to us. I'm an engineer by training, so a lot of what you're saying is new to me. Fortunately, I have read Daniel Kahneman, so I did understand where you're coming from when you mix psychology and economics. So we'll go over to the questions session now. I see in the chat that there are.
Thank you. Thank you, Nives, for your quite interesting presentation. So now I will try to present a very short presentation of the White project, where to frame what we are going to do and to trying to easy the following two sections where we are going to explain a little bit more about the project. So I'm Cruz Borges. I am the project coordinator of the White project. This is a European project funded under the socioeconomic call. We are a group of 7 partners that across Europe, where we are going to trying to increase the understanding on energy system, on the demand side of the energy system model. So the rationale behind the project is that, as Maciej and Nives has already explained, that we have a very high climate ambitions, and energy system model has been very used a lot to frame this climate ambitions, to put this into context. And they have very good model for the energy supply dynamics. But now we are seeing that the accuracy in simulating the effect from the demand side, it's not very good model. Nives has already explained a lot about this part. So what we are going to do in WISE to trying to improve the assessment of energy consumption trends on household by including by using a novel technique that is causal model for inclusion in the energy system model. So we are going to try to focus on these 4 aspects: the energy efficiency, that seems like the key topic, but also we are not going to forget about the distributed generation, the demand response, and the electrification of services. So we are trying to get a very holistic point of view, but the focus is only on households. So the key innovation of the project is that we are going to use causal models for trying to create this, to improve this understanding on the residential behavior. So those are a kind of expert knowledge model. They are not data driven, so they have their particularities. They form a theory, so you need to look for validation into the, let's say, the more natural science, not with the artificial intelligence science and this type of things, not just in the statistic field. And they are important because you can, one of the key points that it's shine is they allow to estimate the impact of interventions and to divide counterfactual, but as they are not data driven. So you can actually estimate these actions even before doing the intervention, okay? So the causal model are just some sort of graph where you point what are the variables that are affected, and you just create a mesh, let's say, of actions, of functions that related each one of the variables. And this, in fact, this is quite similar to the structural equation models and other this kind of techniques that are already used in the past in the social science and economic field. This is a kind of generalization. So what are going to be this is one of the key concepts. The second concept is that we are going to use multi-agent systems in a broad sense. So we are going to start with the behavioral model that is going to simulate the behavior of people at the house. So it's a very bottom-up approach. Then we are going to model the houses and the interaction between the people behavior and the house equipment, let's say, in a broad sense, because we are going to put there electric vehicles, PV panels, cogenerations, electrolyzers, I don't know, this kind of new technologies that appear now. And we are going to investigate if they are going to become relevant or not at household level. And then we are going to scale. I mean, we are going to pass from 1 house to million of houses. And then we are going to be able to plug into this big energy system model that Maciej was talking about in his previous presentation. So we are going to do 5 proof of concept with quite different sites. I'm not going to talk much about this one because in the next section of today's meeting, we are going to go into very high details of each one of them. So thank you everyone for your attentions.
Yep, thank you, Cruz.